Hey everybody, welcome back to another fun and exciting pre-calculus class. Today we'll be jumping into chapter 11, lesson number 7, and that is on page 220 in your book. We'll be talking about the general form, or we also I call it a lot of times the standard form. You've heard me say that the last few lessons. I keep referring to the standard form of the line. All right, so what is it and how can we use it and how can we learn from it? Go ahead and look down at your book, page 220, and let's talk about the standard form or the general form of the line. So you have an AX, and then you have a BY, and you have a C. What is the A? The A is the coefficient of the X. Notice that A cannot be negative. Okay, so you can never have a negative A term. You would always have to turn it positive when you're dealing here with the line equations. And the way that you do that, and you've seen me do it the last few lessons, is just multiply everything by a -1, and that will change the sign. The B term, or the Y term, excuse me, is the B coefficient. So the A is the coefficient of X, the B is the coefficient of Y, and then the C is the constant term. So it doesn't have a letter with it. It's just always on the other side of the equal sign. Notice it also says A, B, and C are not fractions. So we need to convert here to multiply by the LCD, least common denominator. And if that way we can turn everything to no fraction. And that's the way that you have to put these. That's the format that you need for these. Here is a conversion. So basically we're going from this is the standard form, AX plus BY equals C, and we're going to convert that to Y equals MX plus B. So we would take the AX to the other side, that'd be the first step, and then we would divide everything by the B, and you would get Y equals, there's your MX, your M is in a fractional form, okay? And then plus your CB. Typically, you would actually, if those were numbers, you would divide those out. Here's where the formula is. So Y, then the MX. So this M here in this case would be a fraction, negative fraction. And then the CB is right here. In order to get your slope-intercept, though, you would have to divide that out. Now we're converting to what's called intercept form. Remember, intercept form is where the C equals 1. We've done that. Okay, we had a problem, I think it was last lesson, that we actually had to do that. So we just divide everything by C, and then you end up with these fractions, and then you would simplify those fractions out if you can, and get X over A plus Y over B equals 1. When turn the page over to 221, from the general form of the equation, the slope and the y-intercept may be found using m equals negative a over b, okay? And so that's where we just were on that, where we converted it into slope-intercept. So the slope-intercept is going to be negative a over b. So, like, for instance, in this equation right here, 2x plus 3y, we don't even have to figure it out. Remember before we solved it over to y-intercept form, and that's how we knew what the slope was? Well, what they're telling us here is immediately we know that the slope equals negative a over b. So we just take a over b, make it negative, boom, that's our slope. Easy. The x-intercept, the way that you would do that is you take c over a. So here's C, 12. Here's A, 2. Divide 12 by 2. That gives you 6. And it's always the 0 is in the y because it's the x-intercept, because that way we don't go up on the y. The y-intercept, we don't go left or right, so we don't go, the x is always 0. And then it would be C divided by B. So in this case, C is 12 divided by B, which is 3. So there's your B. And that gives us 4. Okay, 12 divided by 3 is 4. All right, example number 2. We'll go ahead and do this one on the screen. Find the general form equation of a straight line with a slope of 5 over 6 passing through the 0.24. All right, so here we go. All right, let's go ahead and look down here and let's write down what we know. All right, so here is our original equation right here. We know that we're looking for a perpendicular to that, and it's going to pass through this point. So let's do this. This is going to be our original equation right here. So we're going to make this our original equation. So in our original equation, we're going to have an A, we're going to have a B, we're going to have a C, we're going to have an M. Okay, so what does A equal? What does B equal? What does C equal? And what does M equal? Well, looking at this original equation, our original equation says that A equals 5. Do you recognize this original equation, right? Yeah, it's the one we just did. So, yeah, they're just kind of taking you full circle here and showing you that there's more that you can do with these equations. The B is going to be -6, and the C is going to be -14. All right, now how do we find the M? The M is missing here. What can we do to find the slope? Well, remember that the slope equals -A over B. Well, we just plug these guys in, right? So here we're going to get our slope is -5 over -6. Look, this one didn't have a negative, but this does. So when we plugged it in, it went to negative. This one doesn't have a negative, but our B over here is negative. So they both ended up being negative. What happens when they're both negative? That means that they are positive. So our slope is 5 over 6. 5 over 6 is how you find the slope. All right, so now we basically have everything that we need. Now we need to do our new equation. All right, so in our new equation, we need to have an A, we need to have a B, we need to have a C, and we need to have an M. Okay? All right, so what is our slope of our new equation? Well, it's a perpendicular line, so we would take our slope of our original equation, and it was 5 over 6. Well, we invert it and make it negative, so that's going to equal -6 over 5. -6 over 5. All we did was flipped it, made it negative. Remember that we want to keep the A positive, so we'll go ahead and just assign that negative to the bottom, and that's fine. You're always trying to keep the A to be positive because that's how it goes in standard form. So I'll take that, remember, and this equals A over -A over B. Okay, so again, we're trying to get all of this done. So this is our slope, so it goes here, 6 over -5. But when we convert it into this, when we get our negative, so that becomes -6 over -5 again. What happens is we come out with just 6 and 5 because that flips that sign. So A is going to be 6 and B is going to be 5. So the question becomes, what is our C in this case? Well, right now we don't know what C is. And you might say, no, C is -14. It was -14 on the original equation. We don't know what it's going to be on the new equation. All right, so we've got our A, B, we've got our slope, and we are ready to find out what C is. We're ready to go ahead and plug it into our equation. So our standard equation, there's points 1 and 2. So we're going to have 6 is our A times our X is 1. This is going to tell us what our C is. That's what we're looking for right now. And then we're going to have a plus. And then in this case, we're going to have a 5 is our B times a -3. That's our Y. And then that equals C. So that's what we're trying to figure out. Do this right here, and we get 6 plus -15 equals C. What is 6 plus -15? That would be -9 equals C. So now we found out that our C is -9. Okay, so there's all the information that we need to form our new equation. So let's go ahead and write our new equation, and we'll put it into standard form. So here we go. we have our A is 6, and that goes with X, plus our B is 5, that goes with Y, and that equals C, which in this case turned out to be -9. That is our equation of a perpendicular line. Now, that was complex, complicated, I know. I'm going to show you a quicker way to do that. Go ahead and look down here at your book real quick on page 222. Compare the given equation of the last example with the equation that you had. So, parallel line, if it's parallel, check this out, 5x minus 6y equals c. So here's the given line, right? So what's the only difference? The only difference is we don't know, in a parallel line, we don't know where the c is. We don't know where that's going to move based on our other line. Okay, but we do know that it's parallel. So what we know is we know that the A stays the same and the B stays the same. The only thing that's going to change is our C. Now, on a perpendicular line, look what happens. The A and the B switch places. That happened when we inverted the fraction. The other thing that happens is our Y term switches signs, and that's where it comes when we make it a negative inverted fraction. Okay, and then again, we don't know what our C is, and that's on the one we just did. We had to find the C after we did that. So let's look over here at the screen, and let me show you these, hopefully in a format that you can, kind of learn from pretty quickly. To find the equation of a perpendicular to the line given in general form, here's what we do. Exchange the coefficients, switch x and y. Take x and y, swap them, and replace the operation between the terms with its inverse, and set the statement equal to c. Learn that. Highlight that. Write that down. This is important. You'll need to know how to do this. The second thing here is to find an equation of a parallel line. This was perpendicular. This is parallel. How do we do that? Everything stays the same. Simply set the statement equal to c. That's all we need to do. So it was equal to whatever it was. Now it's equal to c. All right, let's try to do this one really quickly. All right, so find the general form of the equation of a line perpendicular to that and a line parallel to that. Okay, so we're going to do this twice. Find each line passing through 2, 3. All right, so let's take it. 2x plus 5y equals 8. Let's first of all do it for the parallel. We'll do the easier one first, right? So a stays the same. So a equals 2. B stays the same. It equals 5. The c equals, that's what we don't know. And then the slope stays the same. So the slope in this case is what? It's -2 over 5. That's our slope. -2 over 5 because it's negative a over b. -2 over 5. So all of these things stay the same. The only thing that's going to change is our c. All we have to do is solve this for that point. So we plug this point in. So 2 times 2 plus 5 times 3 equals c. That's all we've got to do. So there we go. We have 4 plus 15 equals c, or 19 equals c. There we go. So let's put 19 here in c. And now we can just, instead of the 8 right there, we're just going to go ahead and get rid of that for now, and we're going to plug in 19 as c. And there is the solution for the parallel part to that line. All right, now we want to do it again, but we want to find it for the perpendicular. So let's go ahead and make that c again. And what we want to do here is, see, remember this one was, these are the old numbers. That's the old ones that we use. That's the first one that we used. So we want to change this, and we want to do, this one's going to be the parallel over here. So the A in the parallel, the B in the parallel, all we do is swap these. So the A becomes 5, put equals. The B becomes the 2, okay? and then it says that we swap this, so it becomes a -2. So here's what we have. We have 5x minus 2y equals c. Now all we have to do is plug in our 2, 3. Just plug your point back in. So 2 goes there, 3 goes there. We end up with 5 times 2 minus 2 times 3 equals c. And then you just go ahead and solve that out. And you would get, let's see, 10 minus 6 equals c. 10 minus 6 is 4 equals c. So in this case, 4 equals c. So we'll just go ahead and plug this back in here. I'll plug it right in there. Okay. All right, erase this. And the only thing that we need to do here is plug in 4. And there is the equation of the perpendicular line. Those solutions are found on page 223. If you missed anything, make sure that you go back and kind of rewind it, watch it again. I know I went pretty quickly through that. It's all there. Go back, watch it again if you need to. Look at the book, compare it, and just follow those simple steps. They're not hard. They're just switching things. It's kind of hard to remember. You may have to go back and look at your book a few times as you're doing your work, but just use those steps to find the perpendicular and the parallel lines to the given line. Okay, that's all I got for you. Have a good one. Bye-bye.